Okay. So okay, so we have two things to discuss today, lecture-wise. The first one is mobile communication and mobility. So I will do that first. It's a little bit dry topic. And then the second one is finish off the UI lecture that was 2 weeks ago. There were some things about the layout and some things about the way we program the behaviors. So I will talk about it after the break. So the first part is about mobile communication mobility. But before I do that, how many of you did lab 1 already? Great. Any trouble with it? I would like to do, I mean, the labs are kind of due on 18th of March, right? So there is no deadline for doing labs. But I did encourage you to do the labs kind of throughout. I would like to do like a code review maybe next week with one of the people's code who submitted lab 1. So if you are keen to have your code reviewed publicly in the class, then make an issue in the issue tracker, and then I will pick that one, okay? So we will discuss a little bit about the linter, we will discuss a little bit about the coding conventions in Java and like the way the structure of the project looks like. So it would be good to use some existing code so then everybody can relate to it. So that's one thing. The second thing is, any of you are doing the 1A? And how far you got?
I failed 3 times to install the Go mobile.
You failed.
I can't get it to link up.
Right. So I did set up the let me just go back to wiki. So if you go to setting up Go mobile, there are some gotchas which are not work exactly as described in the tutorials. So some of the things are described here. Have you checked those things? So if you haven't checked those things, and the official tutorial tells you to do certain things certain way, but it will not work actually. And the code which they have in the tutorial, the bind hello tutorial, will not work neither with the latest Android Studio for some reason. So you have to kind of go around a little bit. So if you check this, it will kind of help you. And then if it still doesn't work, then ask me on the issue tracker. I may just make a simple tutorial. It is actually quite simple, but the problem is that the tutorials don't work. And the way they describe how you should set yourself up is not working with the latest Android Studio, unfortunately. So yeah, so those of you who are working on that, if you cannot get it going, please check the help which I put on the wiki. And then if you still cannot get it going, then I'll make an issue in the issue tracker and I will follow up. I haven't prepared the lab 2A and 3A, but the idea will be sort of similar to the line of work of 1, with the difference that we will not do the sensors. So those people who are doing A will not do the sensors lab. They will do similar things to what the other labs are, with the chat being the final one. But instead of using Firebase, we will use a distributed peer-to-peer network. So we will build our own like a peer-to-peer client, which talks with all the other nodes which are on the swarm, and then you can send messages within the swarm without using the third-party Firebase backup. So it's kind of self-contained chat which works over the existing peer-to-peer messaging. So that would be the final lab, but in the middle we kind of step through towards to the final lab, right? And we will not do the sensors. Okay, so that's the kind of basic updates. And what is this about? We discussed the evolution of the telephony networks on kind of landlines. We touched a little bit about the mobile, but here we sort of dive a little bit into the mobile aspects. And I have a question like, what does it mean? What mobility means to you? What does it mean to have a mobile device? What would you say is the main characteristic of a device which is called mobile? Yeah.
Well, being able to call from anywhere, like communicate from anywhere, and check up information from anywhere.
Yeah. So call, communicate, and check information, right? So voice, audio, and data, you would say. What else? From anywhere. So this is sort of an interesting question, because you can be able to do it while you are moving, or you can be able to do that while the infrastructure is moving, in a sense, right? So you can look at mobility from two angles, right? So let's say I'm in this building and I have Wi-Fi and I can walk in the building, and the Wi-Fi is the same. Like the Wi-Fi doesn't move. I kind of move, but I don't really. So the infrastructure is fixed in a sense, right? The fact that I'm moving and I'm connected to the same Wi-Fi point, access point, doesn't really change anything. And then there is one step further where I can hop from one access point to another seamlessly, right? So if I go far away from one access point that my phone cannot talk to it anymore, it sort of finds the next one to hand me over, right? And then I kind of seamlessly talk over the other one. So we will kind of discuss the communication aspects, but what are the other characteristics? What do you feel is also important?
I mean, entertainment apps like music, like ebooks, games.
Mm-hmm. Yeah, but it kind of boils down to communication, right?
Yeah.
Exactly. So, like, it's really hard to think of something else which doesn't really end up being kind of about communication. That you have the communication kind of available to you at all time, right? So, if we go back before we had the full kind of mobile infrastructure on Earth, there are some locations which don't have it, right? So what you can do is you can kind of carry a big backpack with a big antenna that you have to set up and a big transmitter receiver, and you can use kind of a radio communication, right? So I can carry this backpack as a soldier and go to a desert and then stop, set myself up, set up the big antenna, and talk to somebody, 50 kilometers away, right? Would you consider that a mobile communication? I can talk on the go, right? I'm mobile. I can talk from here, and I can talk from kilometer from here. Is it a mobile communication?
Portable communication.
It's portable communication, right? The term mobile doesn't really kind of fit. So when we kind of conceptually think about mobile, it means it's sort of like portable, sort of like the soldier with the backpack, with the difference that the backpack and the antenna and the transmitter is always on, right? So I can talk here and here and here and all the time, right? I have kind of a continuous connectivity. I don't have to stop, set it up, and then talk. I just have it on the go. So while I'm moving, I have it available to me, right? So, well, before we have the infrastructure, it was not possible, right? We didn't have it. So yeah, so that's the question. What does it mean to be mobile, or to have a mobile device? So able to move or be moved freely or easily. So the portable backpack thing, well, you can move it around, but to have the connectivity, you have to do this setup. You don't have it all the time. yeah, to be mobile also means kind of a in non-technical terms, to be able to change your profession, your place of living, and so on, right? So people are, when you say people are mobile, then it means they can shift to a different town and live in different town or something like this. And then we have some sort of a new phenomena, because we have this kind of always-on infrastructure which makes you connected all the time. So you mentioned entertainment, watching TV, watching movies, playing games, reading stuff. You can work on the go, so you can play and work anywhere at any time because you're sort of always connected. So there are some implications of what mobility is now, because we do have it. We kind of take it for granted, but if you step back a little bit and think about it, then you kind of discover that there is a lot of implications to it. Some are very positive, some are not so positive, and also in the context of disasters and some things that kind of make this connectivity not available, things happen, right? So people feel a little bit uneasy where they get to a location and there is no connectivity, right? Suddenly this infrastructure around you, which was connecting you to the rest of your social circles and to everything, is gone, and then you feel, or not, a bit of a disconnect, right? So this is sort of, nobody really knows what it means because it's relatively new. We didn't have this sort of always-on connectivity and mobility for a very long time to get used to it. We have it enough to develop a lot of services and a lot of expectations and a lot of addictions even, but we still don't fully understand what it means in terms of social organization. And a lot of people don't rely on it that much. They use some aspects of it, but not to the extent than other people do. So there are some definitions of what mobile device is. Some are more or less boring, and some are more or less adequate to the current times. So a small computing device that is easily portable and can be used in various environments. Well, yes, but what this definition is missing is this, it's not just a computing device. We really expect this computing device to be connected to the network, right? I used to have electronic watches, 30 years ago. It's a small computing device which I can carry everywhere and use in different environments. It was waterproof. I could use it in a swimming pool. I wouldn't call it a mobile device, right? First of all, it was kind of not universally computing. It was only computing particular things, which was time and small calculations, and then it was not connected. All right. So the first definition is missing this kind of a connectivity aspect. Okay, so a portable device that uses wireless technologies to transmit and exchange data, right? Yeah. So if you combine those two together, then you probably get some more meaningful thing. Serial telephone, a handheld mobile radio telephone for use in an area divided into small sections, each with its own short-range transmitter receiver. It's a very technical definition of what a cellular phone is, because it sort of explains why we call cellular phone. Why? Because we have this grid. We organize the space into those cells, and within the cell you have a particular transmitter receiver to which you are connected, and if you leave the cell, you get to a different cell, and then you are connected to a different transmitter receiver, right? So that's why we call cell phone a cell phone, because it's inherently built on the concept of those grids, on those cells. And how is called the process of me walking from one cell to the other? Handover, right? So remember that. So handover is the process of the infrastructure handing me over from one transmitter receiver to the other one. And it's a very complicated process. So if you're in a car and you're driving, in the field and you're talking on the phone, you have a voice going all the time between two recipients, right? I mean, between you and the recipient. And then you're getting close to the edge of the cell, right? And you have to be hand over. How does it happen? How the infrastructure knows that from that millisecond, the signal will not be going from this tower, but from this one, so the call gets nicely transmitted that you still talk and you don't hear or see anything, right? It requires a synchronization between the infrastructure and the towers and between your phone, and it has to know that you're getting close to the edge. They have to agree, okay, in 5 seconds we're gonna do the handover. In 4 seconds, 3 seconds, okay, we're doing the handover, and they switch, right? From one particular moment in time, one of the towers stop accepting the signals that it still receives, because it's not like one tower stops hearing your transmissions, it still does, and that one does, right? It can be multiple towers that hear your transmission, but only one is in charge of handling you, right? So this process is called handover. And then you have a handheld telephone for use in area divided into small sections, cells, each with its own short-range transmitter receiver. Also a telephone that communicates by radio waves rather than along cables. Serial phone, radio phone, and wireless telephone. Okay, so all those definitions feel a little bit old. They kind of really focus on telephony, right? As we were discussing before, telephony, okay, is important, but you use data much more than the actual audio on your devices, right? 99% or even more of your time with the phone is not on the phone, it's on the data link. Right, so the main point is this network connectivity. So the wireless networking became the main point, even though historically the infrastructure and the telephony was sort of around the audio signals, same as with the traditional telephony. Here we've seen that very early on the data took kind of a precedence. So being connected and being connected all the time is like the main point. The actual mobility, the fact that you can move around, yeah, it's kind of secondary, because like how often do you really require that you have connectivity on the go? Well, in a car, yes, you're sort of playing a game or doing something in the car, but when you are not in the car, you can stop and do stuff on the phone, and then if you have to walk, you can walk, stop, and do things on the phone, right? I mean, people do things on the phone while walking, but it's more of it's not a necessity. Like you don't have to do stuff on the go most of the time, right? Even navigation is okay if you like look where you have to go and then stop, look where you have to go, right? You don't need that mobility. Okay, so then you have some additional, so you have a lot of positive things, right? So you have the connectivity, which is always on, and you do have mobility, right? But then you have other things. So you have security problems. Yeah, your devices are small, they can be stolen. You are emitting everything over the radio waves, so like sniffing packets became really trivial. With wired infrastructure, you have to get access to the building, to the infrastructure as a hacker to sniff the packets. With wireless, everybody can be sniffing packets and nobody will know, right? It's sort of easy. You do rely on batteries. We have discussed it a little bit. We still are slower than wired connectivity. So bandwidth used to be a bigger issue. It's not a big issue these days. So how many times did you say, okay, I would like to have faster connectivity on the mobile? Unless you're really watching some streaming or something, it's usually just satisfying. You don't really, like, it's not the limiting factor most of the time. Of course, the faster the network, the better, but you can get higher quality video and so on. You have packet loss, of course. So even though you might be using lossless connectivity, they will still be packet loss because of interference, because of environmental factors and so on, and they will have to be retransmitted. Like, you don't have to deal with it, but somewhere in the protocol stack, someone needs to deal with it. You will have disconnections, the famous going with a train into a tunnel. So if you're on a Skype call and then you go into a tunnel, suddenly you have no network, right? And there is nothing you can do about it. It's just normal. So when you're planning apps and planning mobile solutions, you have to take those things into account. And yeah, interference from the environment. All right, so, technically we're not gonna go into physics, but, you need to understand that we have these radio waves, and they are kind of divided by the wavelength into particular classes, and then we try to use a particular wavelength range for a particular purpose. So then the world agrees that, okay, let's use this particular range for this purpose and this for this purpose, right? The longer the wavelength, the longer distance you can transmit it, but you can pack less data, right? The shorter the wavelength, the more data you can pack, because the frequencies are kind of much more compact, right? So you can pack more data, but they penetrate shorter distances, right? So a very obvious case with Wi-Fi. These days you have routers which can do 2.4 gigahertz or 5 gigahertz, right? Which ones you use at home? 2.4 or 5?
Both.
Both. What's the disadvantage and advantage of 5?
Well, you get a lot more speed, but then it might not be available in certain corners of the house.
Exactly. So you have limited range, but if you're in range, you will get better speed, right? But there is a trade-off, right? The trade-off is, if you walk too far away, even though you could get higher speed, you will get shitter speed, right? Because the signal is weaker, right? And you will have a lot of noise and a lot of interference and, packet drop and so on. So in my house, actually, if I'm not sitting next to the freaking router, I'm using 2.4 because I can connect to 5, but I always get slower internet. And how do I know it? By watching YouTube, right? So every time I'm watching YouTube and something is like not too great, it's like, oh, shit, the computer picked 5 instead of 2.4, and I have to switch, right? So if I'm sitting next to the router, then it's fine, it's super fast. But it's really, in my case, it's really short range situation. Okay, so here we have some, some sort of a historical account on things, how they happened, right? So we had, and we still have AM radio. So those are kind of the longest range frequencies that we've used. Then we have the 2G and 3G. We have Wi-Fi and WiMAX. And then we have kind of a close range communication, right? Bluetooth and NFC, right? Because of close range, you can use really high frequencies, yeah?
What's WiMAX?
That's good. Very good.
So, yeah, back in the day.
It's about technology for this industry as well, right? So
that's right. So, so imagine the world where you have telecommunication companies and you have the the telco protocols doing their things for voice and data, right? And a world where the technology is driving Wi-Fi initiatives and kind of bringing higher and higher speeds. So there was a time, and still is, where you can use telecommunication like a data data plan on your phone, or you can switch to Wi-Fi, right? And the data plans were always a little bit laggy, they were always a little bit slower, and they were kind of behind the technological innovations of Wi-Fi, right? Wi-Fi was and is better, faster, more robust. So there was an initiative which was bridging those two, which was as good as Wi-Fi, but allowing kind of a long-range tower setup as the normal GSM network. And that was called WiMAX, right? So it was sort of a bridging technology which had benefits of both worlds, of the GSM and telco world and the kind of non-telco, you know, Google sphere, right? It was superb technology, right? Everybody, all the technologies were saying, yeah, that's great. I mean, it's the best. There are no drawbacks. It's like, technologically is superior to both and offers the benefits of both worlds, right?
And you could use it privately, right? So that was the magic. Suddenly you have
Yeah.
a Wi-Fi with a massive range. Problem is though, if you go beyond the property boundaries, you're considered a telecommunications provider. So it basically was the crowdsource or bottom-up, substitution of the telecommunication network, because suddenly you could talk to your friend using your own WiMAX network, theoretically.
Yeah.
And obviously, who's not keen in that? Well, you pick any of them, any telecom provider of your choice. So that's why
They said, yeah, we don't like it.
That's not going to happen.
We don't like to have people with routers of 10K range, in their homes and talking to friends in the neighbor suburbs for free.
How would anyone communicate if everyone had like a kilometer range on the routers?
There were technological solutions,
would
right?
Be noise.
No, it was sort of, it would work. Right?
Same as with Wi-Fi as well, right? So if you're having a Wi-Fi that sits on the same channel, you have similar issues as well.
That's right.
And WiMAX solved it in a very similar way.
Yeah,
so.
but imagine a kilometer range in Oslo.
Yeah.
We would have some issues, potentially, right? But not everybody would have the WiMAX deployment, right? So, universities could have WiMAX deployments, and you personally at home, you wouldn't. You would be a customer, right? In your suburb, maybe, the Kulturhus would have the WiMAX, but everybody else would be kind of using that one, right? So it's not like, everybody in their flat would have a WiMAX tower, right? But it would really democratize the network infrastructure in a sense. So it would have been a beneficial for anybody but telco companies, right?
I think one of the use cases was to use it as a middle layer backbone, right? So for example, you have a large area that is connected via WiMAX, and then you have Wi-Fi endpoints in those areas that would, serve the user base. But fundamentally, you would have a layer between the telco provider and the actual Wi-Fi Wi-Fi provision. That would be WiMAX, and that would span across a large range, like part of Gjøvik in its entirety. So Telenor wouldn't get a cent of it, right? So,
yeah. That's right. So it was great, but it never really took off for the reason of lobbying and regulations and market forces, right? So technologically it was better. It would have been better. We would have all been better. In fact, there were mobile phone prototypes which were using WiMAX, right? So you have like Nokia had a handset which was equipped in the transmitter receiver parts which would work natively over WiMAX, and it was ready, but it kind of never really happened. There are still some deployments in some cities, but those became kind of a niche market. So so WiMAX was sort of between the GSM and the Wi-Fi in terms of range and in terms of frequency, right? And then on the higher end of frequency band, we have those close range communications, right? So then if you sort of look at the spectrum, you see we started with about 800 megahertz in the early days with the GSM for transmit and receive, right? And then we moved to, in some countries it was 800, in some countries it was 900. And then we've discovered that actually, if you double the frequency, you get more through, double or more. So we kind of switched to 1800 and 1900. And then we've also discovered, hey, actually, if you push it even further, you can get even more, right? So the current mobile specs, go over 2 gig in some cases. So how it all started? Well, you had the wired, we've discussed it before in the class. You have this infrastructure, costly to maintain. So we've discussed it in the context of convergence to IP protocol and Ethernet over the backbone, right? Here it's the same, but with wireless, right? So we had the need for wireless communication. How would we do that? Well, it was kind of working in parallel. So the developments in the wired connectivity and the backbone were independent of the mobile standards and mobile communication. And it was kind of, Europe was leading the pack. So and that's why, GSM. So what GSM stands for? Everybody knows the acronym, but what does it stand for?
It's French, right?
Exactly. So if you say,
Look it up again. Mobile system mobility. I don't know.
Yeah, so that's not the...
Gender skilled migration. Not quite. Yeah, that's
This one.
Yes, that's right. Yes.
Right, so GSM stands for French for Groupe Spécial Mobile. I don't speak French, so I can't pronounce it correctly, but that's where the acronym comes from, right? There was a group of technologists and companies which were driving the innovation in the mobile space, and they were defining the standards, and that's why it kind of took off. Why would you think it would take off in Europe more than anywhere else? Potentially because of density of populations, right? It is sort of I don't know whether you've experienced it in Norway, but we did in New Zealand. New Zealand is kind of a sparsely populated place. So the areas which don't have many people, the telco operators don't really care about those areas, right? So to get internet and mobile connectivity, that costs them a lot of investment for not much return, right? So they just don't bother, right? So in a lot of places, the network connectivity is non-existent, right? Just because of economy of profit making, right? In Europe, you have quite a dense population areas. You have big cities, and the cities are not far apart. So it's kind of relatively, I mean, you have to make the investment to build the towers and everything, but you get quite a rapid return on your investment because you have potentially a lot of customers who will be willing to pay for services, right? And that is potentially why Europe was the sort of the leading, continental Europe was the leading kind of driver. And of course, each country developed their own standard, right? So initially everybody was sort of saying, yeah, we have to jump on this bandwagon, and we'll have to have our own standard for the mobile communication for various reasons. So, if you have, that from market partitioning, right? If you don't have standardized protocols, if all the countries are using their own proprietary protocol, manufacturing equipment is cumbersome, right? I would prefer to manufacture a particular chip or particular card to millions of customers instead of tens or thousands. So it's cheaper to standardize things. Also, if you have devices, like if you drive with your mobile phone from one country to another and it doesn't work, you don't like it as a customer neither, right? So for supply and for demand aspects, standardization is kind of a good thing. What are the forces opposing the standardization? Why would you prefer not to have a standard? Yeah.
Lock-in.
Exactly. So lock-in, and in generally, it's kind of called rent-seeking behavior. So some companies try to prevent new entrants to kind of buy into the space by kind of locking that space, right? But eventually they all agree it's a bad idea to try to do this. It's a better idea, and everybody will be better off if we standardize it. So that's what that's why GSM was formed, and that's why the GSM standards kind of started. So GSM kind of initiated in Europe, and then it took over, right? There was a similar initiative from US, but it was sort of overshadowed by GSM. And there was similar from Japan. So then we have TDMA and CDMA initiatives to kind of divide the how to use the spectrum, how to use the frequencies that are available for the mobile communication, right? So what's the difference between time division and code division multiple access? So I think I have it. No. I mean, it's here, right? So if I have a particular spectrum, I need to divide it in such a way, some smart way, to pack multiple connections at the same time through the frequencies that are kind of passed around, right? Because the operators kind of own the spectrum, they own particular frequencies, and they own the infrastructure. They want to push as much stuff through the particular transmission as possible, right? So they usually do either amplitude modulation or the frequency modulation, right? And the time-based one basically cuts all the transmissions into very small chunks, and then in the particular time frame, the signal that is being transmitted is used for a particular use, right? So you kind of do a time division. So you divide the time that devices communicate into slots, and each slot is used for one channel or one transmission, right? So if I do that, like say I do it 16 times, I can have 16 times in this time frame to be passing back and forth, right? And with code, it's sort of similar, but I am not bound by the way I'm using the time. I'm bound by the way I'm encoding the signal over the transmission. Yeah, you had a question?
Yeah, I was just saying that, asking that, but yeah, you said it.
Okay. So we kind of leave it at that. We don't have to go further down into the way how it works, but I just want you to remember that there are two basic ways of sharing, right? So if I have a transmitter and receiver, and I have a particular frequency spectrum, particular frequency that I can transmit signal back and forth, what can I do? Well, I have basically two choices. I either, for very short time, transmit one signal, stop it, and then transmit another signal, stop it, and so on. And that's based time division, right? So I'm kind of dividing my time when I'm doing the transmissions into very small chunks, and I kind of do round-robin transmissions over those chunks, right? So I divide it into slots, and in each slot I use the signal that I can to transmit the data, right? The other one is I don't do a split in time basis. I kind of always transmit the whole thing, but I just encode the data using a different schema. So I do amplitude modulation, and I kind of encode the signals in such a way that they don't interfere with each other. And then this allows me to pass over the signal multiple things at the same time, right? So then we have some science on channel capacity and how much data can we do and how much interference and cross-contamination we have and how small the channels can be. So obviously, if I have because the splitting of the transmissions introduces additional frequency that I'm kind of that I have, right? So if I have a particular base frequency to transmit the signals, and then I'm doing the splitting, I have another kind of interference frequency for the splitting. If I do the splitting, of course, they don't do it 16 times per second. They want to do as much as possible, right? So if I, for example, split it 1,000 times, then I have a 1 kilohertz base frequency, right? If I ramp it up to million, then I have 1 megahertz. If my base frequency is, say, 1 gig, then I have kind of 1 to 1,000 interference with the splitting, right? And the closer you get the closer those two numbers are, the more interference you have and the less it works. So if you double the frequency, if the GSM moves from 8 8 megahertz, 800 megahertz to 19 or 1800, then I kind of widen the gap. So my time splitting doesn't interfere so much with the higher frequencies, right? Because it's lower down. So there was sort of a natural tendency to kind of go up with the spectrum because it allows me to pack more data. And it's the same with Wi-Fi, right? The higher I go, the more data I can pack, the less interference I have, but the less range I get from the frequency. So, you know, multiple users or multiple communication channels being able to be used. Yeah, the goal was to transmit voice, and there was a, modest requirements for transmitting data, right? Between 9.6 and 56 kilobits per second, right? Have you ever used 56 kilobit per second modems for doing anything? Have you ever exceeded your data cap and you were throttled down to, 56? Yeah, how does it feel? It feels, grueling, right? You cannot do much. You have to switch off downloading graphics or anything because you can't get to anywhere, right? With the modern websites. For text, sort of you can, but... All right, so it started with kind of a 1G, and then we kind of migrated to this CDMA or TDMA over 2G, and the focus was on voice, right? The goal was efficient transmission of voice over multiple channels for multiple users at the same time. And kind of a modest data, right? And people were using it, and it turned out people were using it a lot. They really wanted that to be better, right? So then we have a transitionary period called 2.5. So between 2G and 3G, there was a period where we had something called GPRS. Any of you seen GPRS on the connectivity? Sometimes in some countries you still see that, right? You don't really get 3G or Edge, you kind of get GPRS, right? It is kind of, rather slow, between 56 to 114 kilobits per second transmission, but it is data, right? You're kind of in the middle of nowhere, and you can still get and send data, right? So yeah, in New Zealand you still have it in some of the national parks which are not populated much, and that's where this web-based protocol for browsing web was developed. We discussed that in the previous lecture. So then we had something even better called 2.75G. So why we have this? Well, usually when GSM writes the specs, they say 4G should have such and such speeds or such and such requirements, right? And then the manufacturers and the telco operators, they sometimes cannot meet those requirements. So they roll out kind of intermediate technology, which sort of is towards the requirements. And that was the case with Edge. And you also see, sometimes instead of seeing 3G on your phone, you see Edge, right? And that means, okay, we're not fully 3G yet, we sort of just getting there, and the equipment is a little bit older, the speeds are slower, and so on, right? So with Edge, you got pretty decent 400K. You could send pictures and video and do even VoIP with 400K, right? If you go to GPRS, you can't really do much. With 114, you can send pictures, but it takes a while. And if you try to use VoIP, it will be really bad quality or not working at all, right? With Edge, yeah, it's sort of it's a pre-3G technology, but sometimes some telcos were advertising it as a 3G. And then you have a similar story for third generation, right? So the third generation was first introduced in Japan. Again, you might think, why? Well, it is costly to roll out new things, right? So if you are a telecommunication provider, like in New Zealand, and you have a working, say, 2.5G network, and customers are using it, why would you take millions of dollars investment to roll it into 3G for 4 million population, out of which only part uses the new equipment? You wouldn't, right? So they don't. So what they do? Well, they wait for countries like Japan, for example, to roll out the next generation network, and then they buy relatively cheap all the old equipment that Japan doesn't have anything to do with, right? So then the New Zealand telcos are waiting for a richer country to roll out the next version, so they can buy the previous version, so they kind of run this version, right? And that was kind of how the life in New Zealand was. You were always 2 generations behind the top leading pack, like, you know, Scandinavian countries or Japan. Yeah, so they increased the speeds, and you have, you know, download 168 megabits per second, right? It's a huge improvement, right? So I don't know whether you remember times before 3G, but, you know, between 2G and 3G, it's huge change, right? Suddenly things actually work. Like, you can watch movies, you can actually download stuff on the phone, right? If you go to Edge or the previous technologies, well, it is not that usable. I mean, with the modern apps, right? Okay, and now we have the 4G specs, right? So the 4G says you should have at least 100 megabits. Yeah, 100 gigabits for high-speed mobility. No, yeah. So this is 100 megabits when you're moving fast, right? When the handovers have to happen quite fast. And then when you're stationary, when you're not moving fast, if you connect it to the same tower, you should get up to, you know, or more than 1 gig, right? So your phone should be able to talk with 1 gig data bandwidth if you're kind of stationary. And then if you're moving fast, then it should be a bit slower. So then, you know, there were 2 candidates, WiMAX, big hopes, no uptake, and then LTE, and LTE won, right? So this slide was done a few years back. We knew that that's not gonna fly, but now we know it basically was killed, right? And LTE is the kind of a long-term evolution, and that's where the state of the art was a couple of years ago, and now the 4G is gaining more traction, and you know, it's close to be finalized and rolled out. And there are new work happening for 5G networks. So here is and again, kind of a view over the frequency spectrums and Wi-Fi, right? So with Wi-Fi, we start, like, all the Wi-Fi specs are based on the 802.11 standard. So the 802.11 standard specifies how it is done, how Wi-Fi happens, right? Which OSI protocol layers Wi-Fi supports. So is it just the physical layer, or is it the physical and data layer, or is it the physical data and network layer? Which ones? What do you think?
Physical data and network.
Close. Physical data. So network is still done by TCP, the normal, you know, network stack, right? But we don't use Ethernet. We use something like Ethernet, and we have a MAC layer. We have MAC addresses for the access control and so on for the routers, but it's not Ethernet. It's something kind of similar, but not quite. And the 802.11 kind of defines how it works. So it kind of defines how it works on the physical layer, like how the frequencies and how things are actually done, and then how the access layer, how MAC layer works too, right? And it started with, you know, 802.11a, which was using kind of a wavelength between 35 and 115 meters, and it was able to transmit up to 54 megabits per second, okay? So standard B can only do 11 megabits. How is that an improvement? What do you think?
Better range.
exactly. So this basically was if you have the device next to a router like this, then you can potentially get 54 megs. If you walk a little bit away, you will never get 54, right? The range was really small for the A standard. And the actual effective data transmissions you could get were lower than 11, right? So the standard B said, okay, I mean, that is not working how we hoped for, right? This one is actually better, right? So with B in the normal homes and normal circumstances, you were getting better transmission rates than with A, unless you were really close to the router.
I think in this earlier times, this is the brutto transmission rate, the gross transmission rate, meaning it's divided by all devices, right?
Yeah,
so
that's right.
And in practice, it was more like you had 2 megabit connectivity because
that's right.
It's too much load on your network. So those are all the max.
Those are all max. Those are hypothetical ones which you will never get, right?
That's right.
Yeah. So then there was B. Then we had some progression up to standard G, which back again to 54, and it was a bit more realistic. Again, you will not get it, right? And those transmission rates are on the data link layer. They don't take into account any headers or anything you're doing, right? So for example, if you go, yeah, let's make effective. There is a nice yeah, you have edge. Yeah, this one. So nope.
You're looking for the standards for it.
Yeah, there is yeah, I found it yesterday. There is a nice yeah, that's the multiple in. It's quite a nice comparison. Like yeah, I will find it and link it in the slides. There was a comparison of how fast your effective data rates were depending on what you were using. So if you were using Skype with VoIP packets, which tend to be really small, then the overheads with the headers is so much bigger than your effective rate is pretty much flat. You don't get any progression of the speed with the standards, right? So even though the standard says, okay, you can get 600, you were not getting any closer to that. But if you were using the very large, like 1.5 1,500 bytes packets, the maximum ones on the MAC layer, then you could see a very nice progression of the speeds that you were getting, in regards to the bandwidth that was advertised. So it kind of those figures are sort of very yeah, it's a proxy to what you really will get, right? It's not by any means adequate. Yeah. All right, so then, so we started with GSM with the up to 4G and 5G. Then we talked about WiMAX, which was great, but kind of never happened. And then we talked about Wi-Fi, and now we're going even further in the spectrum, and we're talking about the Bluetooth, right? So why do we have Bluetooth? Well, Ericsson decided that it would be really good to have some sort of protocol for close range communication to open cars, to do headphones connectivity, keyboards, things like that, like up to a few meters.
Is it the PAN concepts related to it, person area network concepts?
Yeah, I think it came after. Okay. Yeah, but it's sort of, yeah, it's the idea is that you have some connectivity, which is neither, the ones which we had, which is standardized, and then device manufacturers can use it, right? What do you use Bluetooth for? You use it for keyboard, mouse, sensors, phones can talk to each other over Bluetooth, and so on. And then there was this kind of a personal area network concept, which pushed, Bluetooth 4, which is low energy. So the normal one was actually a little bit wider range, but consumed more battery. We discovered that it's not needed. Like, we actually don't need that big range. You can open your car from being next to the car. You don't have to open your car, from meters away. But your device will consume much less power because of that, right? So Bluetooth 4 was kind of a major innovation which happened a few years back, which kind of reduced the range a little bit. It improved the data transmission rates, and it kind of reduced the consumption of the battery. Yep. Is it secure? Well, not really. There are some security measures built in, but typically you can have a number of different attacks which will circumvent the way it works. So then what do you think was the next? So okay, now we have the mobile communication over kilometers. We have Wi-Fi communication over, I don't know what the latest standard is. And by the way, if you go to the, we kind of stopped the discussion on N. What's the latest Wi-Fi spec? What's the latest 802.11 spec? Well, officially it's called 2016. They don't have the letter acronym yet. The last one with the letter acronyms was called A. Yeah. So there was a 2012, and then there is a number of standards. There is so the so the last one which so the AX was trying to provide throughputs of 4 times the one of AC, right? And then the AC currently was so if you were using a 5G band with the highest frequency channels, you could get you could get 433 megabits per channel, and then I think they had 8 of them. So yeah, effectively you could get something close to 2 gig. So yeah, you would have to check it, right? The important thing is that we moved. So this is an important concept. With N, we moved from a single transmitter receiver to being able to multiplex the same connectivity over multiple transmitter receiver, right? So we have this setup called multiple input, multiple output antennas, which allow us at the same time to transmit signal over multiple channels, right? Using the power capacity of each transmitter, right? So before that, we were only using one antenna, and now if you have routers or Wi-Fi stations which have multiple antennas, it's not just a gimmick. It's actually they are able to transmit concurrently the same, not the same, but the same communication over multiple transmitter receiver channels. Yeah, let me see how much we have Yeah, let's do a little bit more and then we'll have a break. So we have the long range of GSM standards. You know, we have the shorter range for Wi-Fi, but we can do more communication with that. Then we get to a couple of meters with Bluetooth. What's the next one? Well, the next one is like ID, identification, and payments, for example, where you want contactless payment, but you want the reader and the card to be relatively close to each other. You don't want this to be long range. You don't want this to be, you know, meters. You want it to be quite close, you know, 10, 20 centimeters or even closer, right? So we want some sort of radio communication, which is contactless. We don't need to like swipe things. We don't need the contact to actually happen. So it's contactless, but which is, you know, based on radio, but very close, right? So that's what, you know, NFC basically is. So NFC was sort of based on RFID technology. RFID has been used for, you know, much longer for tagging shop items and so on. And it's sort of similar. It is kind of compatible with the modern RFID contactless technology. There are active and passive ones. So the passive ones can be read by the readers. The active ones can emit something. They can emit data themselves. And you can have the active ones being powered. So you may have some active ones which have battery built in, or you can have active ones which are powered by the radio field from outside. So I can have a card which is active, but it doesn't work until it is within the field. It's like the wireless charging, right? So you can have a wireless chargers where you can place your phone on and get charged, and they are kind of used by the electromagnetic field. So the same happens with the active ones, which are kind of powered by the external field, and they emit particular signal. So they kind of usually operate up to 10 centimeters, and they're kind of a limited data exchange. And they usually have sort of like secure component which doesn't allow the thing to be read, but it allows some sort of so you can have security by making something read-only, so things cannot be changed, or you can make things to be encoded in such a way that only a verified reader can read. Not everybody can read that particular bit, right, or piece of information. So a couple of years ago, the lecturer who was running the course, he did some experiments with the NFC, and they kind of he installed NFC reader and used his phone as a kind of authentication device for letting him in, right? Which is kind of funny because that was maybe 6 years ago. So we had those swipe card readers. So you have to swipe your card to get entry. And he installed the NFC reader, so he could use his phone to go in. And now we have the NFC readers built into the readers by our doors. So this card has a RFID tag, and it's kind of basically uses the similar technology. The problem is, because of the secure element which is on the RFID tag, I cannot replicate this tag on the phone, right? So if it didn't have that secure element, I could, and then I could use my phone in place of my card. But because of that security, like technologically it's possible, but it's kind of protected. So yeah, so that's the old reader with the swipe, and now all of them were replaced in this building for the ones with the NFC, right? So Okay, there is another one. So NFC and Bluetooth are kind of great, but for some use cases, you want to have even better protocols for radio communication, and one of such protocols is ANT+. So ANT+ is even more robust protocol for transmitting data with low power circumstances, and it's usually used for personal area networks, for sensors, for heart rate monitors, for bicycles, to transmit cadence and speed to some kind of controller. So some of the Android phones, they have ANT+ built in. And they usually, like Android usually adapts the kind of a new standards very early on. iOS adapts them eventually. It doesn't support ANT+ even now. NFC came up with iPhone 6, so for many generations the iPhone was not allowing NFC, but they do need it for Apple Pay, right? So at some point the devices have to be equipped with NFC, otherwise Apple wouldn't be able to jump on the mobile wallets, bandwagon. So they kind of allowed it from iPhone 6 onwards. Yeah, I have a few more slides about the security for wireless. We will discuss security in a separate lecture, so there will be mobile security lecture, so I will discuss it a little bit more. Here is just some takeaways, right? So one takeaway is that don't use web. Web is trivial to break. You just need to make observations of about 2 minutes of somebody using web, and then you collected enough data that you can use statistical cryptanalysis and crack the password from the packets that you've sniffed. And sniffing the packets is trivial, right? So if you are determined, you can easily do that. And it's so easy that some new regulations came about preventing financial institutions using web because it's just too easy to do. WAP and Web 2, you should use Web 2. It's much better than the normal one. The normal one uses this protocol. The second version uses more improved encryption algorithms, and they are much harder to crack. This one, I don't remember like where this data comes from. I was trying to find it yesterday, but I couldn't. But I will try to find out how it is, how hard it is to crack web. I vaguely remember that you had to use a number of servers from Amazon to kind of do the cracking, that it wasn't that trivial. This one you can do on your laptop. You don't need a lot of computing power. But for this one, I think that 20 minutes was with maybe 100 Amazon instances kind of trying to crack it. There are some kind of interesting legal issues. For many years, US was blocking exporting of high cryptography protocols. So they were limiting things to a point where the government could break it, kind of brute force it. Nowadays, we don't do that. Like we know it's a bad idea, but few years back, BlackBerry phones were still banned in Saudi Arabia because they were too secure. The government couldn't oversee what is actually happening. So the question is, how secure do you want your data to be? Would you prefer technology which makes nobody able to access your data on your phone? Or do you think, government and law enforcement should be able to crack your phone if need be, if people are doing something illegal? So it is a question of morality in a sense, because technologically we are getting really close to be able to do non-crackable devices and non-crackable crypto, right? By non-crackable, I mean if you don't make mistakes. So, for example, you have encryption which allows you to encrypt your partitions, and those encryptions typically are non-breakable. You cannot brute force to crack into those partitions. But if you allow some malware or some sort of a backdoor onto your system, which runs and observes what your system is doing, then even though the algorithms are not breakable, you basically have a security hole in your system, because whoever needs to read your secure documents from your secure partition can do that if you have some sort of daemon which observes what happens on your computer, right? From outside, it's not possible, but from inside it is. It's the same with the secure messengers, right? If I'm using Signal with peer-to-peer messaging to Christopher, and someone wants to see what I'm telling him, it's technically not possible. But if he has installed some sort of spyware on his phone, then it doesn't matter how secure the protocol is. Someone can see what we're talking about, right? Both his messages and my messages. So, you know, but should the technology be allowed to be super secure? And yeah, the general understanding now of security is that yes, it's a good idea to have that. Yeah, so we will talk a little bit about it more. So a final slide, back to the stack. TCP, layer 3 network, used, layer 4, yeah, IP is on the network. Used for communication that we don't want to lose any packets, right? UDP, same layer 4 for communications that we allow to lose some packets. So video transmission, voice transmission, if we lost one packet, retransmitting it doesn't make sense. I mean, we've already watching new frames. So if we lost one frame or lost previous some sort of audio data, then we don't care, right? Do you know what broadcast, multicast, and peer-to-peer networking is? Yep.
I don't know what peer-to-peer is.
You know or you don't?
I know what peer-to-peer is.
Yep.
When you have two clients talking to each other, just sending information between each other, and you might have a whole group of people just sharing information.
That's right.
So, torrent files, for example, you can download a really large file
Yes.
without a big server sending it to you with 100 other people.
That's right.
Chunks and sending what they receive.
Exactly. And you need a little bit of coordination to know where to download it from and who has what, right? So you need this sort of infrastructure to know who is where, who I can get that particular chunk from, and how to get it. So for download, that's exactly like BitTorrent is sort of the state of the art. For messaging, there are some protocols which allow you to message either a group or a particular node in a swarm of peer-to-peer nodes, and you have to have some sort of ways of doing it. And you either favor security, in which case you don't care about efficiency that much, so you may flood the network with something to prevent tracking of who talks to whom, for example, or you prefer robustness and efficiency, in which case you want to find the kind of a closest path to pass your message to the particular peer, right? Because you don't want to be connected to everybody and everybody to everybody, because that's not efficient neither, right? You want only to be connected to people that you frequently discuss things with, or that, but you know, then again, you're kind of sacrificing the topology may expose some social connectivity if you do that, right? So you have to play with the trade-offs. It depends what you favor, right? And then we have connectionless versus connection-oriented communication. So that kind of relates a little bit to this, right? So connectionless means I can, let's say we have a peer-to-peer network and I need to send something to Christopher, but I'm not directly connected to him. So I may kind of gossip to the neighborhood nodes saying, I have this message, you know, flood it, gossip to others. And then eventually he will get it. He will decrypt it and he will say, oh yeah, that's from Mariusz. Okay, that's great, right? But there was no direct connection between me and him. And then connection-oriented is I will establish kind of a link over SSH or over something that I am directly connected to my recipient and then push the communication. It is relevant to for a number of applications, and with the designs of the logic of the applications that you're doing, right? So if I have a phone and I need to talk to my backend server, of course, while I'm talking, it is connection oriented, right? But on a higher level, do I need to maintain this connection through the life of the application, or do I want to always kind of make it, stateless and kind of broken in a sense that I only connect to get what I need and then I disconnect, right? Most of the time, that's better. Most of the time, kind of opting for connecting, getting something, and disconnecting is better than maintaining the connection, mainly because you have no guarantees that with the mobile device you can maintain the connectivity for an extended period of time. Yeah, so that's with the mobile phones, you are at mercy of the telecommunication providers, for example, using the firewalls. If you're using Wi-Fi, that's less of an issue because the firewalls are sort of maintained by the infrastructure operators here. So if NTNU doesn't have any rules about the traffic and you're using Wi-Fi, then you just don't have any rules about the traffic. But if you're using data over your data plan with a particular network operator, telco, then you are at the mercy of the telco. If they block port 22 or 25, then the port is blocked and there is nothing you can do, right? You cannot run SSH server on your phone. So you may ask them to open certain ports, but they will have some default policies. And the default policies are quite strict. So they basically block everything apart from HTTP traffic. So you can browse the web, but nothing can connect to you. And usually that's how the setup is, right?
Just consumers.
Yeah, as a consumer, exactly. So you can test it. You can download some sort of a server software on your phone and go on data plan and then try to connect to your phone from your PC. And if you cannot, that's probably the reason, right? You will probably hit the firewalls of your telco operators. So that's why peer-to-peer networking is kind of hard. You cannot host BitTorrent content from your mobile phone. And you cannot sort of use broadcasts to discover peers nearby. But you have, over Wi-Fi, you don't have those constraints. And also with the upcoming 5G standard, some of those things are taken away. There is a peer-to-peer networking and there is a direct connectivity, and potentially the firewall rules will be less conservative. Having said that, majority of people don't need to run any server software on their phones, right? So for majority of people, it's actually safer to have those strict firewalls rules made by the operators, because it prevents Trojans and some backdoor being installed on their phones and allow kind of attackers to connect to them. All right, so let's have a break. After the break, we will talk a little bit about the UI to finish the UI lecture, and then we can talk about the labs. So I would say 10 minutes break. switch this. So what we will do now is we will go back to the interface lecture, and I will talk a little bit about the things that we haven't talked about when we were discussing the UI. Before I do that, there was just one comment to last week's lecture about the databases. When you are setting up the database on Android, you have to remember that you're making an app that's gonna be released potentially, right? I mean, you may not be releasing your app, which is fine, but normally when you are a developer, mobile developer, you're working on an app that is released, okay? Once the app is released, it's out of your control, and you cannot force users to update. So, and you cannot force users to do certain things neither, okay? So let's say you've developed an app, you've released version 1.0, and then 1 million people using it, okay? And then you've discovered that you really need some new functionality, so you've changed your database, and you've updated your version to 1.1, okay? And now you've released it. What will happen is you will have users who are using 1.0, and you have users who are updating to 1.1, and you have new users who started with 1.1, okay? And now you have a new version, you've added a new table, and then you have a new version of database, and you've released your app version 1.2, okay? So now you have users 1.0, you have users 1.1, and you have users 1.2, okay? So now your database in 3 states. You have a database version with the same which was 1.0, database version which is 1.1, and database version which is 1.2. And then let's say 1.3, 1.4, 1.5, nothing happens to the database, and you have a new version of the app which is 2.0, which again changed something in the database, okay? So now your database has 4 versions, the 1.0, 1.1, 1.2, and 2.0. And you name your versions 1, 2, 3, 4, okay? So now what happens is some users from 1.1 will update to 2.0, okay? So you have to plan that. You have to have a migration path that you are adding the tables and deleting the tables, which were between 1 and 4, to make it consistent, compliant. Some users will go from 2.4, some go with 3.2 to 4, and some people may want to downgrade. They may want to go from 4 to 2, okay? Usually the downgrade is not such a big deal because Google Play and the normal usage of the apps prevent users to downgrade. They have to uninstall the app and then install the lower version. You cannot downgrade from the version you have, typically, right? The NDK, ADB and the Android setup prevents you to install an app with the version lower than the one you have. So if you have version 4, and someone wants to install version 3, the Android will say, no, 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 you can't do that, right? So users will have to uninstall 4 and install 3. If your database is created and deleted on uninstall and install, then you're sweet. But if your database is stored on the SD card and uninstalling the app keeps the database and installing a new app links to the app, to the database, you have to deal with that, right? So dealing with databases is actually a nightmare if you have to think about all those versions and all the changes that you're making, like I've added an attribute, or I've deleted a table, or I've done something to the database, okay? So don't do it lightly, okay? The advice is, if you design your database, design it, play with it, test it, run it with a limited number of users, change your schema, play with it again. If you spend, a month or 2 playing with your database, making sure that the tables and everything you need from a database is solid, then release it through Google Play and to the public, right? Don't release a database where you've inserted a new column just to realize a week later that actually I need a new table and I want to redo it, because it's a lot of maintenance, it's a lot of cost. Every change to a database, it's big change. Adding an attribute, adding a column is a big change. Adding a new table is a big change. Don't do it lightly, okay? So spend some time designing your database, test it, make sure that it's kind of feature proof for the next couple of iterations of your app, and then release it. Otherwise, you will get yourself into trouble.
So is it a viable approach to have a separate app that you release as a new version, basically?
Some people do that, yeah. Some people get into a point where they say, okay, screw it. I'm just releasing a new app. It's not a new version. I'm just doing a backward incompatible rollover, okay? I rename my app to version 2, and it's not compatible with the other app. You can have both at the same time. You know, I'm choosing a reset because the maintenance nightmare is too much, okay? So, you know, with the normal app without the database, it's still a bit of a hassle because you have different people using different versions, but at least your updates are kind of streamlined. With a database, it's a big issue, right? So you have two choices. You have three choices. One, you are really careful and releasing the database changes only when you really need to, so you don't have many of them. Second option is at some point you say, screw it, I just have to have a new app version, and it's just change a package, right? Your package has V1, V2, that's it, you're gone. It's a new app. It can have the same name, can have everything the same, right? You just have to communicate to the users that there is a new version. Or three, you try not to use database, you try to use a backend RESTful service or some content provider that deals with the content that you need to store and read, okay? It doesn't really solve the database issues. You usually have to have some local storage. You have to store stuff yourself. You can switch to using files, but it's even worse. At least with database, the Android helps you to version the databases. With file storage on your own, you have to version everything yourself. But what can you do into the cloud? You probably could do with the cloud, right? The local storage, of course, has advantages. It's available offline and so on and so forth. And often you cannot do the option 3. You cannot do cloud stuff. So you then back to those two. Yep.
When storing locally, like a database locally or in the cloud, why is it such a hassle to upgrade between versions of the database? Yes, columns change, some columns go away, and new ones might appear, maybe there's a new table, but why can't it just be a relatively simple part of the update process to change whatever entry you had in the 1.0 database through whatever 1.1, 1.2, 1.3, so you whenever you create a new or release a new version of the database, you may create along with it like a process to migrate a user's data from one to the other. And you then delete it from the old one, and you can even keep statistics of how many.
No, that's exactly what you need to do. That's how it works.
And then creating from 1.1 to 1.2 with all the iterations between, you're gonna be jumping between every single one of them. So that's gonna take a little bit longer and have a little bit more database transactions, but that's a very small price to pay to having to deal with that.
That's right. So typically that's a very good strategy, right? So then the strategy is you release version 1, then you release version 2, which makes a transition from 1 to 2. So people from 1 can upgrade to 2, right? Then you've released version 3, which has a transition from 1 to 2 and new transitions from 2 to 3, right? And then if someone upgrades from 1 to 4, they have to first upgrade to 2, then to 3, then to 4, right? But the logic of the code that does that gets more and more complicated, right? Because if someone upgrades from 1 to 4, you have to say, okay, now upgrade to 2, then to 3, then to 4. But if someone upgrades from 3, you have to say, okay, you upgrade from 3 to 4. So even though you organize it into blocks, you still need to manage the logic of how people are being upgraded.
Well, that's an if statement.
Yes, it's a complicated.
You check the version number, and if the version number is this, you start that process.
That's correct. So that's what I'm saying. If you have few of those, it's not a big deal. Yeah. But if you have hundreds of those, suddenly your if statement becomes unmanageable, right?
Yeah. I think the other thing about data is you can't get it wrong. Like if you get your UI wrong, you post yet another update to your suite. If you have lost the data in your alter table process or whatever, you lost the data, right? So,
exactly. Yes, exactly. So if you, yeah, so that's a very good point. If you have some sort of UI glitch, you just release a patch, people update, nothing happened. But if you had some database glitch and you wiped people's data on the phone, there is no going back. The data has been wiped. You migrated the data wrongly or something, right? So then, that's what I'm saying. I mean, what you said works perfectly fine if you have a manageable number of upgrades. And that's the way you do it. You do it the kind of step-by-step migrations. But you know, it doesn't scale. It doesn't scale to hundreds or thousands of updates, right? So, you know, do it wisely and then plan for the long road, exactly. Okay, any other questions about the database? You don't normally deal with that for the labs because, you know, you don't care and you're not releasing your app. And you may get caught. Sometimes you've, you know, you have a database schema. You've deployed your app, it works, everything works fine, and say, yeah, I need a new column. You've added new column, you've deployed the app. If you do a complete refresh install, everything works fine. If you try to make the app over the app that you've already deployed, suddenly you have exceptions like, well, the column doesn't exist. It's like, how? Why doesn't it exist? I'm creating it here. But you didn't bump the version number of the database, so the new database was not created. You're still using the old database, which doesn't have that column, right? And you will see that yourself. So then you say, okay, you either wipe the app and reinstall it, and then you have everything fine, or you have to bump the version number, which, you know, overrides the old database, creates the new one, and so on, right? So that's also kind of a question, like how do you deal with updates? Do you because you know you have different strategies. Let's say you've added a new column, then what you want to do is you just add a new column and put some data or default data there, right? In your update, you don't touch the old database, you leave it. But if you deleted a table and added a new table or you reorganize it, maybe it's easier to wipe everything. I mean, to backup everything, clean everything, recreate everything, and read the data from the backup, right? So you have to plan those things. Okay, so UI. Well, I believe we stopped around here. So I was discussing the hierarchical views, right? So the views follow the traditional hierarchy. You have root, and then you have children. It's almost all UI widget toolkits use the same metaphor, right? You have some sort of UI components which you can use, and they are composed of children that you can manipulate. So you have a top-level window or view which has children, and the children may have children, and so on, right? So in Android you have a view group, which kind of is a parent consisting of some views, and then a view is a parent that has sub views or some components inside the view, right? Usually, if that happens, you kind of update the view to a view group, which means the view group has children. An individual view doesn't have children, right? So the view is like a leaf, and then the view group is sort of has a role of a parent. But those are interfaces, right? So you can have a view that is a view group as well. Yep.
Are the views UI elements like buttons or labels?
That's right. Yes, correct. So a view group can hold other views or view groups inside, and then they offer, the views are kind of a control. So some buttons and text fields are actually view groups themselves, because if you think about it, the button is composed of the label and the shadowing and all those things. So it's actually a view group in its own, right? Okay. So how do you do the layouts? So we discussed that you need some form of dynamic laying things out depending on the screen size and depending on the device that you have and the resolutions that you have. So you can do two ways. So one way is you declare in the code that the view is of particular type, and then you populate the children. You do it all programmatically, right? The other way is you use XML, and then when you need to instantiate a particular layout, you say, I want the resource, I want to inflate a resource from that particular XML, and then it kind of reads the XML, generates the in-memory objects for you, and then you insert them into the view. What are the advantages of one over the other? What do you think? When would you do it in XML, and when would you do it in the code? So let's say I have a screen, yeah, and I have to create 10 text fields. Would you do it in XML, or would you do it programmatically? I have to do hundreds of text fields.
Oh, okay.
Yeah, exactly. So usually you pick one or the other, how laborious it is, right? If the layout has a couple of UI elements, you do it in XML, right? But if the layout has, you know, a large number of similar elements, you will do it programmatically because it's just easier. But why do we have both?
I mean, isn't doing it programmatically creating XML anyways that is supposed to be read?
Say it again?
Doesn't generating the UI programmatically doesn't that just do the same as just having an XML file, except you have a program which generates the XML file?
No, so the programmatically doesn't generate XML. There is no XML step when you're doing it programmatically. So here you have the programmatic example. So I have the, I have the set content view to TV, and text view, I just said it's a new text view. It has a text, and I'm just inserted it. So I've just instantiated an activity with the view of a text view, and I have no XML for it. I've just done the single view that I have programmatically. I've instantiated it and set the text, and then, you know, initiated the content, right? If you were doing the, if you were to do it with XML, you would have an XML that has a text view field, and you set the label, like what the text is, and then you would say inflate. You would basically set the content view to the XML handle that has that XML, right? So those 2 lines of code would be gone, and that line would have the inflation of the layout from XML. Yeah. And like this one doesn't involve any XML at all. If the XML doesn't exist, it's never created, doesn't exist.
What about all of the different margins, sizes?
You would have to do it in code.
So does it violate the idea of separating code from presentation?
Exactly.
Oops.
Yes. So if you're doing it this way, some things are kind of easier, because as I said, if you have to create a UI with, say, I don't know what your threshold is like, but about 10 is for me. If I have to create something with 10 buttons, I'm like really thinking, do I really have to do it by mouse and, like, you know, dragging 10 things onto the view? Or can I just write a loop that can generate those 10 buttons for me, right? How do I want the buttons to be? Like 3 in a row, or, you know, maybe I will use grid array and just generate a view programmatically, right? But if it's less than 10, I'm okay. I just design it, right? But as Chris pointed out, you know, programmatic UI has a problem. And the problem is that it's the programmer doing the UI. Should the programmers be responsible for doing the UI, or should be the UI people responsible for doing the UI? Right? Yeah. The UI people should be doing that, right? Exactly. So we want to separate the logic from the presentation in such a way that people working on the logic don't mess up with the presentation, and people working on the presentation don't mess up with the logic, right? So if we have in a team, we have a programmer and the UI person. The UI person will be dealing with the UI, and the programmer will be dealing with the logic. And you don't want the code to be, you know, mixed up, right? So That's why we have this model of separating the presentation from the program. And it was kind of inspired by the web development. So in web development, initially, we mixed up the two things as well, right? You were working on your HTML, on the content, and at the same time, you were laying things out and arranging it and, you know, doing things. But we said that's kind of a bad idea. We should separate it, right? So now we have HTML and CSS, right? CSS is responsible for arranging where things are, how they look like. And then HTML is for what is the content, right? What is the text? What are the actual elements that need to be laid out? So we have a kind of a separation of the application UI from application logic. And it is like this. Java file, the program should deal with the logic, and XML files should deal with the layouts, with the presentation. It makes it easy to maintain. It makes it easier to separate the roles. It makes it easier to separate the team. And it makes it easier to reuse the presentations for various logic aspects of the app. So reuse of the logic and the reuse of XML layouts is kind of separated and can be dealt separately, right? If I were to, like, if I have a little bit more complex logic here for setting up the UI, and I want to have another activity which also sets things up similar way, it's very hard for me to reuse it. I would have to copy and paste this code, right? But if I have it in XML, it's very simple because I just say, okay, this activity uses the same XML as the other one, and off you go, right? It's trivial. So, as I said, it doesn't mean you should do everything in XML. Sometimes it's just too tedious. Sometimes, you know, if you really have to deal with a number of elements that it's too tedious to do manually, you as a programmer will feel it should be a loop, okay? That should be a loop. If you really feel that should be a loop, do it in code. But do it in code in such a way that you do as much as you can in XML and do as little as you can in the code, okay? So for example, if you were to have this problem, as I said, you have your phone and you need, let's say you need 9 buttons, okay? 3 in a row, okay? So, and you may need to have some header and some footer. Then make a layout where you have the header and the footer in XML. Make the content in the middle to be an element that is generated by the code, but make the individual buttons also being read from XML, so then the designer can decide what is the font, what is the color, what's everything about the buttons, right? And in the code, you will only have a loop saying, give me, inflate me the button, and I will lay them 3 in a row in 3 by 3 square, right? So you can do very little in the code, but you can also do very little in the XML, but you still leave the designer or the UI expert ability to manipulate the fonts, manipulate the color, manipulate the shape of the button. You just don't have 9 buttons because that would be tedious as well, right? The designer, if he has or she has 9 buttons to change the color and so on, that's not what you want. You just want to do it in one place and have it for all the buttons, right? So you can kind of do this. So, yeah?
Alternatively, is there a tool that generates XML by code?
Yeah, so we typically don't do that, right? The XML has to be hand-driven. So you could, but we normally don't do that. I haven't had any cases where that would be useful. So normally what happens is you design some sort of a skeleton XML by hand, set what the components are inside XML, and then in the code you can freely mix and match, and you can use it, and you can use loops and things like this. Have you heard of? Well, you technically could do it. You could generate some XML by code, but
it's kind of a non-automated process because you're basically injecting it into a manual process using Android Studio to re-inject the XML into the code, right? So it's like you're making your life unnecessarily hard by introducing this
extra step.
This extra step.
Yeah, exactly.
So
yeah. So typically we do everything in XML layout wise and logic in the Java code. If the XML becomes too big or too tedious, you are thinking of ways of making your life easier. And if you can reuse some of the elements, then you split it into smaller XML files and the code will manage that, right? So you make the code manage the chunks. Because what you've done for assignment 1, you just have one XML per activity. And the XML has everything, right? But doesn't need to be this way. You can organize, you know, for everything you are dealing with, you can have a separate XML. For a button, you can have a separate XML. And then in XML, you can import it. You can say, here is the button whose definition is that XML, right? And then you can reuse it in different layouts. And also, you can link it with the code, and you can kind of mix and match. So it's very flexible, right? The simple use cases, you have just one XML layout with everything in it per activity, but you can really make it very modular and very robust. And yeah, you are familiar with the XML layouts. You have, again, the ability to do it, what you see is what you get kind of thing with the mouse. And it got really good lately. And you can still edit the parameters, the properties in the XML file. And as I was explaining before, from experience, I use both. These days, I would use both, and I would try to keep the XML relatively tidy and well organized so I can have kind of a quick overview of what I need. So if I need to add particular property to the text view, I would usually do it in XML. You know, it's just easier for me. You have the IntelliSense, you have the, you know, completions. So if you want a text being bold or whatever, it's sort of a little bit more intuitive for me. It might be more intuitive for you to do it with the UI. Yeah, it's agnostic. I mean, you choose what is easier for you to do. And then you have a number of different things. So for example, image view, you have the layouts, how it wraps with the container. So if you say if you say wrap content, the image view will kind of contract to the size of the content. So it will kind of minimize itself to what it needs. If you say match parent, what it will be, it will kind of expand to sort of fill in the space of the parent, how much parent allocated to it, right? And then, yeah, as we were discussing, if you're using XML, it's just a one-liner. Basically, you point to the main XML, but you have to make sure that that's a layout for the whole view. It's like it points to the root of what you have, right? What you can do is you can have instead of doing that, what you can do is you can rearrange the layouts depending on how you want things to be displayed, but you have the chunks done independently as XML. As let's say for this use case here, we had 3 XML. We had the top one for the header, the content, and the footer. I can have an XML which sets those 3 things up, but I can also do it in code. I can say, okay, instantiate me the linear layout in a horizontal or vertical way. And if the font is in landscape, I want it to be horizontal. If the font is in portrait, I want it to be vertical. And then load me the header, content, and footer this way, or header, content, and footer this way. And then inject you inflate the XML files and then instantiate them manually, right? In which case you would have 3 lines or 4 lines before that, and then you would set this to the root of the view. You getting it? So you don't have to use it either this way or this way. You can mix, right? So you are inflating things from XML files, and then you're setting them up depending on the orientation of the phone. I mean, you can do that with XML as well, right? With XML, you can say there is an XML for portrait and XML with landscape. In portrait, I have them like this. In portrait, in landscape, I have them from left to right, like this. You can do that with XML too. But then you have to have two XML files. And if you're modifying something, you kind of need to do it in two places. Whereas if you just do it in code, you sort of have it in one place. But it's sort of a programmer's responsibility now, not the designers. The designers typically don't touch the code. They only touch the XML, right? So yeah, there are some trade-offs. Depending what you're doing, you pick one or the other. So then there were some questions about this notation. So the ID means, it kind of refers to an integer ID that we index things by. So the ID means, okay, it will be a numerical ID. We use the text, so there is some sort of a DNS resolving the numerical IDs to name, human readable names, because you or I would have really hard time remembering the generated IDs to refer to them. It's much easier to refer to some sort of naming convention. So here we use the name, right? So ID/name resolves to a particular integer. You can just keep it in the back of the mind. At means that that the parser should parse and expand the rest of the ID string and identify it as an ID resource, right? So that means the rest will be an ID. And then the plus means generate a new one, inject a new one into the r.java file, because we're just generating a new one, right? If you try to generate a new ID with the same name twice, you will get a problem. So then typically it doesn't mean you should delete the plus. Usually it means you should change the name. Sometimes you use this without the plus. Sometimes you're referring to an existing ID, especially if you're saying this element, this view is next to something on the right or on the left or under or above, right? And you need to refer to what you mean. Then you would say add ID, and then you would point to the component in your view which you refer to. So then you would use it without the plus. And then you have system namespace, where you have things prefixed with Android. So those things live in the system namespace. So you may use to refer to some layout, or you may need to refer to some property, or you may need to refer to some icon, like a system icon, where you want to instantiate, a new file or something. Then you would use this kind of a standard resource called Android, and then you would have the rest depending on what you are referring to. If you're referring to an ID, you would have an ID. If you're referring to some sort of a string or icon, you would have the icon. So there are different things you can refer on the system level to. Yeah, so you have a large number of attributes that you're using in XML. As I said, Android Studio has IntelliSense, so it can help you with filling up the things. Most system things are prefixed with Android colon. So Android colon with a different, so ID is ID, layouts is layouts, and you have other ones that you will use. And then you have those wrap content and fill parent. That's what we discussed before. The fill parent has been renamed to match parent from API level 8. It doesn't matter for you anymore. You just use match parent everywhere you need to use this. There was a slight different semantics between fill parent and match parent between version 8 and 9. But we up to 27, so you're probably not gonna go all the way down to this. So you are using match parent for now. Don't use absolute units, of course. We've discussed that. Don't use pixels. Use device-independent units, so DP. You can use the same device-independent units for text, size of the text. It's a little bit similar to HTML. You don't want to set the fonts to a particular size. You want to say it's bigger or biggest or whatever. Or you can set it to SP, which is device-independent size for fonts. And use relative measures for everything. So use DP, rob content, and match parent, and things like that. So the layouts will kind of expand and contract depending on the resolution of the device and the size. Okay, so then we have common layouts, right? So what's frame layout? Well, frame layout is, yeah, I'm gonna discuss it in next slides. So we basically have kind of general layouts that are the most common, right? So in 99.9% of cases, you will use one of those four. So the simplest one is the frame layout. Basically, it's the layout for containing a single object, right? So if you have something that has just one thing in it, it will be a frame layout. So it's a blank space on your screen that can be filled up by a single object, a picture or a button or text, whatever you have. So the children are by default pinned to the left upper corner of the frame layout, but you can change the pinning. You can move it to center or center, whatever, right? But the default, if you don't change the attribute, it's the left upper corner. And you can specify the gravity property, like if you, so what is gravity? You normally don't have the ability to resize the window, right? The window is what it is. You know, if I have a view here, I can make it smaller or bigger, right? But on the PC, you can test it. And what it means is, like, if you display the content on a bigger or smaller device, what will happen to the content? What will happen to the content if I have device, you know, 4 times with density of the device I'm testing it on? What will happen to the content? Will it kind of be clinging to the left edge, or will it be kind of changed depending on the, like, you know, how we are filling up the space, basically, right? So the easiest way to test it is to run the emulator and kind of drag the size or change the size of the display to kind of see what happens to the elements. Flip them, landscape portrait as well. So the gravity is like to what this element is attached in such a way that how the extra space is being added. Linear layout, that's the second simplest. Linear layout allows you to add children in one-by-one fashion next to each other. And you can do it either horizontally or vertically. You cannot mix. So if you declared my linear layout is a vertical layout, then you have one under the other. If you say add child, it's under. Add child under, right? If you say horizontal, it's like from left to right. But you can change it, the orientation as well. You can say it's either from left to right or from right to left, right? And then by adding children, by adding children programmatically, you have them placed in a particular order, or you just place them in the XML. So that one is quite useful for containing buttons, like on the footer. So I have 2 buttons, then you would use linear layout with next to each other. For panels, like the problem we were discussing, that I have a header content in the footer, I would use a linear layout for that. So then what if you want to have things like this with the left side, the content, and the right side, and you want to have the upper part here and lower part here? What would you have to do?
Upper part and lower part of what?
So you have something kind of, you have some content here on the left side and some content on the right side. And then this, what you would like to do is you would like to have something in the upper part and something in the lower part. So there are 2 things that you want to display here, one up and one down. What would you need to do? Yes, exactly. You would use the linear layout here, which is horizontal, and the way it's set up this way. And then you would add this as the middle one would be another linear layout, which is ordered vertically, and it has two children, upper and lower, right? So you have one linear layout embedded in another one as a child. And you can mix and match that, right? At some point, you get, yeah, so that's how the linear layout looks like. We're setting it up saying it's vertical, which means from top to bottom by default. We have the edit text as a first child, edit text as a second child, edit text as a third child, and then we have a button which is at the bottom, right? And we basically say that the gravity for the button is to the right, so the right side pulls the button towards it. So the button is sort of aligned to the right side of the container. We said that all those three text fields fill up the space of the parent, and then the actual layout also fills space of its own parent, right? But it has a padding. So as you see, this linear layout doesn't go all the way to the edge of the screen. It only goes 16 device-independent pixels to the screen on this and this end, because we said there is a padding left and padding right. There is no padding on the top and no padding on the bottom, so it means that we will use the whole size on up and down spectrum. And then we said that those things, those edit texts, fill up the parent. It should be match parent now, right? The example is from ancient times when we still had the fill parent keyword. The compiler will complain if you try to use it now. And we did rob content, so it means like vertically the height is as needed only. It's not bigger than needed, whereas it is. What would happen if I said rob content for the width of that field? What would happen? Because it's empty, it would become kind of very small because it doesn't have anything in it. So it would become sort of just line here, right? If I added some content to it and redrew it, it would become as big as the content. But because now it's empty, it would be very tiny, and I would not be able to even click on it, right? So that's why for text fields, usually you use fill parent. For labels that already have a predefined text, you may use rob content to display them. But for entry fields, you have to predefine how big they should be, even if they don't have anything in it. Okay, so then we have the final one is interesting. So we have a message, right? So we want this one and this one to be just one-liners, but we want the message to fill up the middle part to be kind of big, right? So we said, okay, the width is easy. We made it to all the way to this edge, but for the height, we have a little bit of a puzzle. We said, okay, it's just empty. It's 0 pixels, right? Yet it sort of looks as if it expands all the way to the bottom, right? So why is that? It is because we've added the weight for the layout, right? So with linear layouts, you can have different components expand or contract depending on the weight they are given. And I haven't given any weight to anything else apart from the weight I given to the message, right? So the other ones will have the weight 0, and this one will have weight 1, which means it will take all the empty space that's available to it. So even though I said the height is 0, the height actually is, because normally this button, you know, if this is 0, that kind of ends here, then the button comes. And then I have a lot of empty space, which I have to do something with, right? And this empty space is managed by the weight. And the weight given 1 to this guy means, okay, it will take all the empty space, right? So that's what happens to this message component. It took up all the empty space. The wait is a bit annoying. Like in this particular simple case, dealing with the, yeah?
So there is empty space on the left and right side of the text fields above. So
but that's because of the padding.
Yeah, so
yeah.
There's empty space there.
It's not empty anymore. It's used for the padding.
Oh, so the padding is occupying the space?
Yes,
okay.
That's right.
I was just wondering, like, what happens if you have empty space somewhere and, like, which isn't logical for the text field to have, but you have weight 1 on it. What does it do?
So by empty space, I mean the non-allocated space. If the space has been allocated to padding, it's not empty anymore. The padding occupies it. But so if we parse this file, right, I have this rectangle from top to bottom 16 pixels long, and this one already occupied for the padding. I have this occupied by the first, second, and 0 by third text fields, and the button will occupy a little bit of space, and then the rest is non-declared. It's like up for grabs, like we didn't use it, right? So then if I didn't set this, the whole thing would end here with the buttons sitting in here, and that's it, right? And the rest of the space is just unoccupied. But because I said wait, it means I am actually want to allocate all this non-allocated space to the element that has the highest weight based relatively to the weight of other components. So if we have, let's say we've made a mental change, okay? I've said weight of the first one is half, weight of the second one is half, and weight of this one is 1. How do you think the layout would look like? So I said half, half, 1. Yeah?
The top or 2 would take up a quarter of the screen, and then subject would be the same, and then message would have the bottom half.
Exactly. Yes, exactly. So that's exactly what would happen. The rendering engine would sum up all the weights. So half plus 1 is 2. And then half of 2 is quarter. Half of 2 is quarter. And 1 of 2 is half. And it would allocate the space according to that formula, right?
So the weights don't need to be normalized.
The weights don't have to be normalized. The system will renormalize it, right? It is kind of a practice to normalize it to 1 usually, right? Because then scanning it sort of tells you how big the elements are, right? So normally I would say quarter, quarter, half, right? So I will normalize it for the sake of just normalizing it. But you don't have to. It will be normalized. So that's one annoying property, right? Because if you have non-normalized entries and then you want to add another, let's say you want to add a BCC field or CC field, it's like it goes to hell every time you introduce a change, right? Even if you normalized it and you want to introduce CC field, you have to go and modify all the weights all the way, right? And it's kind of annoying, right? So linear layout allows you to do things like this with a relative stretching of some components, but apart from a very simple use cases, it's actually tedious and it's hard to maintain. So that's why we have relative layout, right? Relative layout solves 2 problems. First of all, it solves the problem of stretching and arranging the elements because it uses different mechanisms than the weight. The second problem is that with relative layout, you can do this with up and down in a single layout. You don't need to embed one layout into the other layout. You can say, I want this to be on the left, I want this to be on the right, and I want this to be above this, and they are both in the middle. So you have a language and you have relationships using relative layout to express the relationships of all those 4 elements. You know, imagine that it's up and down again in a single layout. So most of the time, people actually default to relative layout because it's the most flexible and the most powerful layouts there is, and you can basically express anything in it, right? So if you become familiar with doing relative layouts, it's probably the one you'll be using most of the time. But as I said, for simple button layouts, if you have two buttons next to each other, then relative layout is an overkill. You don't need all this machinery. Linear layout is all you need. So sometimes, you may kind of question yourself, do I really need relative layout? If the answer is yes, of course, go for it. But if you have 2 or 3 components which are next to each other, and linear layout is the way to go, just use linear layout instead. So this one is super flexible, and you have things like layout below, align with the parent, right? So for example, here we have a spinner, and we want the spinner to be next to the what do we want the spinner to be? 2 times, right? So this one is called. So I have 2 spinners. I have one spinner called times, and I have one spinner called dates, and I want the dates to be aligned to the parent on the left side. So I'm kind of aligning the date spinner to be aligned here, and I want the time spinner to be aligned on the right. So this one aligns here, and I want the I want the dates to be on the left side of times, right? So I kind of express the relationships and so on in XML using those sort of primitives that I have. You can kind of do it using the graphical drag and drop as well. You can sort of try to do that using the mouse, or you can express it in XML this way. So then I have the button which says, okay, align to the right. So what's the difference here? I'm not using gravity. I don't have the gravity, and I don't have the weight, right? So gravity and weight are kind of properties of the linear layout. For a relative layout, I have slightly different concepts to laying things out. And you can basically, if you were to, what would it take for me to drag this button to the bottom now? What would I have to do?
Also align to bottom?
Yes, I would basically would have to say align parent bottom true, right? So I would have to align not only to the right edge, but also to the bottom of the parent, right? So then I would kind of drag that to the bottom because the parent feels the parent of the button is the relative layout, and the relative layout says we should fill up the parent. So we should fill up the whole space. Yeah, sometimes it turns out the logic is not what you think it is, and on some phones it's a little bit messy, right? So I did have experience that using relative layouts, sometimes inconsistent across devices, so which is kind of unfortunate. So you have to test it, right? Sometimes it works the way you expect it to work. Sometimes it's slightly off, not exactly the way you think it will work. So sometimes this, this putting the button here may or may not work. But if you use the relative layout, the linear layout, they tend to be much more stable across all the devices that you will have, right? So sometimes I had to switch. I had kind of a complex, I had a sort of a complex UI with relative layout, and I had to go back and change it to be a nested linear layout layouts, because that was more consistent across devices. Yep.
Is there an effective or efficient way to test this across different devices? I mean, you can boot up emulators, but they each take like 2 minutes to start.
Yeah.
So can you? There's no efficient way to like just change the screen size.
No.
Pixel definition and density,
No. Okay. So unfortunately, it is a bit of a manual process, and use the emulators as much as you can. If you have, we do have multiple devices, so I usually have like 5 or 6 different devices I kind of tested on, but there is no really any way there. I was looking because for web, there are cloud services which allow you to deploy something, and they basically take screenshots of your app running with different browsers, different versions, and they give you all the screenshots, and you can kind of see how it looks like, you know, in Firefox version such and such, and Chrome version such and such, on Windows and on Mac, and so on, right? So you get, you know, a gazillion of different screenshots, and you can kind of see how consistent your UI looks like. I was looking for something similar for mobile, because that would make it much easier, but there isn't. So it would be kind of a good service, good business model, I think, for testing a mobile apps, to have something like that. That you basically download an APK, you run it, take a screenshot using different emulators, you script everything, and then you send the pictures back, and people would be happy, right? That would be awesome, but I don't think service like that exists.
You can present it as a bachelor thesis for next year.
You could, yeah. I don't think technologically it's very hard. You just have to script the ability to bootstrap the emulators, install the app, run it, and take a screenshot, right? It's doable. Yeah, anyway, you have to do kind of a manual testing, unfortunately. And then you know, if you go to Google Play, I think the last time I went was like 3 weeks ago, and it was 2,100 different devices with different versions that you would potentially need to test on, right? There is no way you can manually do that. You can test on 10, maybe 20, but that's it, right? So you will always have devices on which something goes wrong, right? So the UI bugs are kind of hard because they don't throw an exception. Like if your button is in the wrong spot on some devices, it's, you know, you will not know about it, right? So yeah, it's kind of hard to do that.
Why do these things happen? Because we're just talking about a canvas with like pixel 0, 0 to whatever resolution it has. Why is it so goddamn complicated to fit stuff along different devices? I mean, it should be easy.
But I think that's the issue, right? So we have a logical detachment, abstraction from the physical representation, right? If we do everything for fixed size with, you know, raster-based layouts, right, where we know the coordinate system, then it's easy. But here you're talking about, you know, shifting orientations, various device sizes, proportions that are changing, and you want to model as flexible as possible here, right? So
yeah.
We don't use any reference to any pixel apart from the padding, right? So
yeah, that's right.
So, and all the rest should be automatically managed. So that's the issue. If you know your device, iPhone, well, you have a reasonably safe outcome, right? So because hardware and software is right sized and fitted, right? So
yeah.
So 1/10 of the screen will always be 1/10 of the screen, no matter how many pixels that is. So why is it a problem to move a button and align it to the bottom? Oh no, on this phone the bottom isn't the bottom of the screen. You see, on this phone the bottom is not the bottom because.
Yeah, I think there was proportions, and in the end it boils down to the vendor as well, right?
Exactly.
So
exactly. It boils down to the vendor implementations often, right? So as Chris was saying, here we don't, like, here we do a little bit. We define the pixels, right? So we want, for example, the times and the button to be relatively same size. That's why we said, okay, they are both 96 device independent pixels, right? We could do it differently. We could do it fully relative as well, because I can align this button to this component on the left and right edge as well. That's what I should do. That would be cleaner, right? But if we did that, then there is no absolute pixels or device-independent pixels anywhere here, right? It's all relative. And then the way it kind of implements this relative organizing of the layouts depends on the implementation. And sometimes they are a little bit buggy, right? So, yeah, I did have cases where the things were not attached or aligned to the things that they should. And it might be just a bug of the implementation of the vendor.
And one question that I have. How can you control the padding between the two spinners here right now? Because is it?
Yeah, you can set margins and you can set paddings for them.
Yeah. Okay.
Yeah.
Okay.
So you can have padding attached to the spinner.
Yeah.
Yeah, and then you can have it.
Cool.
It's also a question, should you pad it on the date spinner or on the time spinner, right? Which one has the padding? You can do both, but then you have to divide your padding into half, right? But you can, yeah, you can do that. So usually if you have some sort of a complex relationships between your components, relative layout is the best. Most of the time, relative layout is the best. It is most powerful, okay, but it's also the most buggy one, right? So if you really want your app to be used by 2,000 different devices, chances of this not working on all the phones is much higher than relative layout, linear layout not working on the phones. Linear layout is much more bulletproof. It works, you can bet on it that it will work correctly on all the devices, right? And from my experience, I never observed any glitches with linear layout. I did observe glitches with the relative layout because of the complexity of the laying things out, basically. Okay, and then the final one is a table layout. It's sort of like a linear layout, but in 2D, right? So you have a grid, and you have cells, and then you populate the cells. So with our original problem with the 3x3 buttons, you probably would be fine doing the grid layout. But if the grid layout is 3x3, you can basically do the rows and populate it in XML, right? But if I were to, yeah, with 3x3, I probably wouldn't already. It's already too tedious, like 9 things. I would have to have 3 rows and 3 columns, right? It's already a bit too tedious. I would say, okay, I basically have, I would isolate the row, and I would kind of in a loop do 3 rows for my 3 buttons. And I would only do this as a single XML file, right? I wouldn't repeat that 3 times. Here we kind of repeated it twice, right? So we have 1 row and another row, and we've added 2 text views to both of those rows. But it's kind of a lot of stuff already, right? And they seem to be exactly the same, like this one and this one seem to be exactly the same, aligned to the left or right. The only thing changed is the text and the behavior. And the text and the behavior you can do programmatically very easy. Attach different, you know, callbacks in a loop. So, you know, just make your life easy, as easy as possible. Last year I had some students doing a kind of a game, and they had things like, I think it was either 2 or 3 by like 5, right? And then in XML, you have those 15 things that you manually kind of set up. And it's like, it's so painful to see because you have to spend so much time like fiddling with it. You should just have a loop. Okay, so there are different view groups that you can use. You have a gallery, you have a grid view, list view, scroll view, web view, right? Those are important. So web view is kind of allows you to have HTML content with JavaScript. You can turn it off or turn it on, but you can basically render any URL in your app. Very convenient. You should use it for the feeds. Scroll view. Well, yeah. So when I click on the content of the feed, if it has graphics, it should display me the graphics. And you don't want to be handling that manually. You just want the web view to display that.
What do you mean? Feeds are.
Scroll view. You will use scroll view as well because you will have content that goes beyond the size of the screen. So scroll views are relatively easy to use, and they basically allow you to scroll the content up and down. They are a little bit confusing if you have a list, right? Because so if I imagine that I have some, okay, so I have some footer, I have some header, and I have a list view in the middle, right? And the header kind of grows, so it kind of becomes a little bit bigger, right? So the header became bigger, then I have the list view, and then the footer is not visible, right? If I drag by the header, I can scroll everything up and see the footer. But if I drag on the list view, I'm only dragging the list view items. I cannot drag the rest. So when you have kind of
list view with a list of things, dragging your finger over a list view usually scrolls the list view, right? Not the parent. So you have to arrange your things kind of somehow logically that it kind of makes sense for the user, right? So for example, if you have a list view and you have some footer, that's usually a bad design, because usually the user will not see the footer. Unless everything always fits on one screen, there is no scrolling of the whole thing, right? So with the list view, usually what happens is you have whatever changes size above the list view, and then you have the list view as the last element for scrolling things. It depends what you're doing. List view is an interesting one. It basically allows you to do a list of items, and you can scroll it up and down. And each element is each element is its own. You can declare this inside an XML file and then just inflate it, right? So that's usually the best way to do list views. You just declare, okay, what is my cell? What do I have inside? Do I have a text or image or icons or how it looks like? You can use relative layout for it. And then you have in your list view adapter, you inflate it every time you need to generate a list view. Generate a view for the list view item. And gallery is similar, but it allows like scrolling up left and right. And then grid view is sort of like it's similar to table layout, but it's more graphical. It's sort of each of this is a XML. And then you have a number of input controls like buttons, text fields, toggles, and so on, sliders. So you just go onto the Android side and check, spinners, daytime pickers. It's not, typical widget library for various elements. And you can instantiate them in XML, set up all the properties in XML, and then in the code you just say find by ID, you find it, and then you can read or set some values from it. So data transfers you always do programmatically. Visual aspects you set in XML. Should you initiate the text in the XML, or should you initiate the text in the program? Well, if it's a static text, if it doesn't change, then XML. If you read it from a preferences or something, then of course, programmatically. All right, so the final thing is how you handle the events. Again, you have two ways of handling the events. So one way is how Chris showed it in the class before. You basically register, you find the element that you need to register a callback on, and you write the code as a on-click listener that you set to this button, right? Have you done it like this for handling your buttons? Yeah. There is an alternative way as well. You can actually link a code in the XML of what happens on click. So you have events in the XML. Oops, I don't have an XML example here. But you can say a particular method of my class will be called when on-click event is generated in the UI. And the method basically has to have, it has to be a void method with a name and the view as a parameter, right? And it has to be a public method. So in your activity, if you declare a public method, say, what's that button is? We don't know what the button is. So you say it, my button on click, and then you pass a view as a parameter, and then your behavior of what happens when the button is clicked. And here you say on click, my button on click method as a text, as a string. The Android runtime will wire up that string to the method that you've just declared, and it will kind of make the behavior of the button on click to call the method that you've just declared, right? Personally, I don't quite like it for two reasons. One reason is that it's very easy to make a typo, and then if you mistype the name of the method, then you will have a problem. Although Android Studio should catch it, right? I haven't tested it with the latest one, but it should be able to tell you, okay, the name, something is wrong with the name.
It doesn't exist.
Yeah, then exactly. The other one is that you sort of, again, mixing a little bit the logic, the behavior with the presentation. I personally believe the logic should live with the code and the presentation should live with the presentation. So I kind of like doing that. It's it's like extra 2 lines of code that you have to do, but I think it makes the separation cleaner. But I'm not orthodox about it. Like you can use both ways, right? Yeah.
What's best for performance?
This. So for performance, this will be faster. Yeah. But again, why? It doesn't matter. It's human scales. It's reactions to human doing stuff, right? So the performance doesn't matter. Yeah. Anything else about?
No,
So
that's-
you have the events. So that's, you have the normal click, like tap, long click, like press and hold for a while, focus change. That's tricky. You have to have some sort of a stylus or something that can hover over, because that is where you iterate of where the focus is, right? That one is tricky. Key presses, touch events, and then I'm not sure.
How would you do that?
Yeah, I'm not sure if that one exists anymore. It used to be that Android had a menu button, a button which was in the shape of a menu, and then depending of where you are in the view hierarchy, pressing that button was calling on create context menu, right? That might be gone actually. So.
What keys do you have now? I mean, if you have a keyboard connected to your phone, otherwise you don't have keys.
Yeah, so the key is for the virtual keyboard. So when the virtual keyboard shows up and you press A or press any of the keys, then you will have the on-key events, which you can handle. So when you, for example, typing password or typing things, you can actually handle the presses of the keyboard or store them, which comes really handy if you're writing a keylogger to steal somebody's passwords, right?
You can even do it to calculate how much time you need to write.
Yeah.
That's something.
Yeah, that's right.
Still there in the API.
Yeah, so I'm not sure how would you use it? Yeah, because there is no kind of button which enforces that. And dialog boxes. No, not dialog boxes. The progress bars. Most of the time when you're testing your app, things happen so fast that you don't need to communicate to the user that the user is waiting, because the emulator works relatively fast and your phones are quite modern. If your app is installed on an old device or like a small resource device, things will take longer. So even though it feels unnecessary to have a progress bar for the user, put them in, right? Because if it's so fast that the user doesn't see it, then it doesn't matter. But if it takes a bit longer, then the user is given some feedback. Okay, we have to go. So that's all.
How much?
Yeah, that was it. So we covered. Yeah.
It's a long one as well.
It took a while. I know, 3 hours.